Welcome to the Ketone webinar. We could not be more excited about the topic or the experts we've assembled to discuss this very interesting opportunity to modify how you age, but also to address a variety of pathologies with food-like therapies. My name is Dr. Greg Bailey. I'm the CEO of Juvenescence. Juvenescence is a drug development company working on therapies, whether conventional pharmaceuticals, tissue and cellular regeneration, or clinically validated supplements, foods, or dietary ingredients that will allow you to live 8 to 10 years longer healthy. Key part is healthy. We started the company in 2017, and have so far created a pipeline of 6 pharmaceutical therapies, 4 supplements to achieve the goal of a longer, healthy life. To achieve the goal of adding 8 to 10 years of healthy living to your lives in a robust fashion, it will be through prevention. So we're very fortunate a few years ago to meet Dr. Eric Verdin and Dr. John Newman at the Buck Institute, who had a novel ketone ester that had demonstrated extraordinary abilities that impacted longevity, cardiovascular, and neurological health in a mammalian model. One of the esters has been launched as a consumer product called Metabolic Switch. It's available today in the United States and should be available in Europe and the UK in the next 6 to 9 months. Furthermore, it's my great pleasure to announce for the first time that our scientists, collaborating with the scientists of the Buck, are working on new molecules to utilize ketone esters that may play a role in pharmaceutical therapies for heart failure and neurological disorders, going through a conventional regulatory pathway. Our goal for our company is to be a dominant player in ketone esters, whether it be pharmaceutical, food, or dietary ingredients to improve your health. Everything keto. Historically, the #1 way to live longer healthy was caloric restriction. The expert panelists today will discuss how potentially through food or dietary ingredients or pharmaceutical therapies, you can augment or replace caloric restriction. Most specifically, this is why it's important to your family and you and your friends in modifying your health. So it's my pleasure to introduce our moderator, a world-class athlete, one of the leading scientists in the area of ketones, and who, like myself, has embraced this in her own life, Dr. Brianna Stubbs.
Thank you for the kind introduction, Greg, and thank you everyone in the audience for joining us today. Very excited to be moderating today's webinar. For those of you who don't know who I am the lead translational scientist at the Buck Institute for Research on Aging in California. The Buck is the first independent biomedical institute that's focused solely on the biology of aging. And the mission of the Buck is to help everyone to live better, longer. I've been researching ketosis now for about 10 years, starting off looking at how ketones could be leveraged as a super fuel for athletes and special forces, which was somewhat born out of my second life as an athlete on the Great Britain rowing team. But it's been terrifically exciting to see that research explode. And now I focus my research on how ketones and keto metabolism can modulate aging biology alongside Dr. Newman, who's on our panel today. So yes, my primary focus of my research is looking at how exogenous ketones can be translated to impact on aging. And so that's really enough about me. I want to give as much time as possible to our panelists, and we're going to kick off with an introduction from Dr. Jonathan Little.
I'm Jonathan Little. I'm a PhD scientist and happy to be part of the panel today. I lead the exercise metabolism and inflammation laboratory at UBC in Kelowna, British Columbia, Canada. And we conduct studies using kind of a molecule to community approach. So we study everything from basic molecular pathways in cells all the way up to clinical trials where we partner with healthcare providers and try to implement strategies in the community. We've got the goal of optimizing lifestyle interventions to treat, prevent, and reverse metabolic disease and reduce chronic inflammatory conditions with a focus primarily on type 2 diabetes. In the last few years, we've been conducting experimental physiology studies and clinical trials using low carbohydrate ketogenic diets and exogenous ketones in humans.
I can go next. Hi, everyone, and thank you all for joining us. It's going to be a really interesting conversation this morning, morning for me anyway. I'm John Newman. I'm a geriatrician and a basic scientist at the Buck Institute for Research on Aging and also at the University of California in San Francisco. So as a geriatrician, I'm a physician who specializes in the complex problems of older adults. My basic science in the laboratory and in clinical translational research is focused on the role of the ketone body system and ketone bodies themselves in these complex problems of older adults. And why is a geriatrician interested in ketone bodies? Briefly, as Greg mentioned, the study of caloric restriction as a way to affect biological mechanisms of aging goes back a long, long time. And understanding those mechanisms that link caloric restriction to aging has led to many of the drugs that are now in clinical trials to target aging. And ketone bodies, of course, are made in your bodies, as we'll talk about more later, during caloric restriction and fasting. And the question over the last few years has been, is that coincidence or is that biology? And as you'll hear about a lot in the next 45 minutes, it's biology. So my lab studies the role of our own body's ketone system as we age, how it might be a resilience or vulnerability factor as we age and protecting us from diseases of aging, and particularly the role of the ketone system in disorders of the aging brain, like dementia and delirium, as I'll talk about more. It's also been a really fun for me over the last few years to work with Greg and Colin and others at Juvenescence as one of the scientific co-founders of BHB Therapeutics, and now of the new joint venture that Greg mentioned just a few minutes ago. Peter, you want to go next?
Thanks, John, and thanks for the opportunity to be here to the organizers. It's a pleasure. My name is Peter Crawford. I'm at the University of Minnesota. I'm an adult cardiologist and physician scientist, overseeing a basic and translational research program dedicated to understanding the metabolic origins of disease. I also serve as Associate Dean for Research Operations at the University of Minnesota Medical School as well. So for over 15 years, my research program has been devoted to understanding the metabolism, the turnover, and the signaling through ketone bodies in manners that may improve health and health span. Ketone bodies are conserved throughout the domains of life. So this means that even the smallest microorganisms that evolutionarily speaking are many, many billions of years old, including all the way through all the mammals, including us, leverage ketone bodies for nutrient homeostasis and flexibility in a variety of states. And it's really that circumstance of nutrient flexibility that ketone bodies may be the key towards in terms of understanding their metabolism, their ability to tune mitochondrial behavior, and their ability to overall signal in a way that improves our health. Our interest in my group has been devoted predominantly in the space of heart failure and cardiometabolic syndromes associated with obesity and non-alcoholic fatty liver disease. Although recently we've taken interest and have been funded to do so in domains related to neurodegenerative disease amelioration, as well as understanding cancer tumorigenesis as well. So there are a variety of applications, obviously, that we're very interested in and committed to understanding at a highly mechanistic level. Pleasure to be here and learn from this panel and share with you today.
Right, so the format for our discussion today was we're going to start off by talking about some of the fundamentals of ketone biology, and then we're going to hear from all of the panelists a little bit more detail about the emerging roles of ketones in your field of research, and finally getting the thoughts of the panelists on what are the next big questions and opportunities in the ketone space. So all of you listening in, please feel free to put questions in the chat. We are going to have a question and answer at the end. So we'll answer all questions at the end. Thank you. Okay, so going back to this first topic, which is background to ketosis. So I'm going to start with asking Dr. Little if you could please describe some of the processes that most people think about when we talk about getting into ketosis, or what people think of when they hear the word keto through changing diet.
Yeah, I'm happy to answer that one, Brianna. So I think it's easiest. Sorry, it's giving me a. You can hear me, right, Brianna? It was giving me a warning sign there. Yeah. I think it's easiest if we think of endogenous ketosis, as Dr. Crawford mentioned. It's an evolutionary conserved process. And it's designed, I think, primarily, the easiest way to think of it is designed to ensure that your brain has appropriate fuel when food or carbohydrates are scarce. So under normal circumstances, most tissues in your body will switch between using glucose or fatty acids for fuel, but your brain normally uses glucose because fatty acids can't really cross the blood-brain barrier efficiently, so the brain needs glucose, and everyone's probably heard of that, right? Your brain runs on glucose. But if food or carbohydrates are scarce, we need a backup mechanism because our brain is pretty important and it's a pretty hungry metabolic organ. And so the way to do this is to take fatty acids, your liver converts them to ketones, and those ketones are smaller molecules that can cross the blood-brain barrier and feed the brain. And your brain loves ketones. So when they're around, your brain will use ketones preferentially, even preferentially over glucose. And there's two ways to really get into ketosis through diet. One is fasting or starving yourself, and the other is a ketogenic diet. That's when you typically eat less than 30 grams per day. So you're eating a very low carbohydrate, high fat diet. So fasting and a low carb diet aren't exactly the same thing, but they have a lot of the same effects. And what happens is that your body takes those fat stores, like I mentioned. Essentially, everyone has unlimited fat stores. So this is a fuel source that you can tap into. Your liver will convert the fatty acids to ketones so that you can feed the brain and other tissues. And so ketosis just means that there's detectable ketones in your blood. The metabolic response to fasting and a ketogenic diet are obviously more complex than just ketones. There's a bunch of changes to hormones and rates of lipolysis and gluconeogenesis, but the increase in blood ketones is a key part. So ketones can be used as fuel, like I said, by the brain, other tissues, heart and skeletal muscle, but there's also a bunch of other very interesting effects of ketones on the body, which I think we'll probably hear more about today in the panel.
Yeah, I think that's where we're going to go next, because really when the research into ketones started, people were looking at ketones as this backup fuel, as you said, primarily for the brain. And it's really only in the last sort of 10, 15 years that people have started to find out about these other roles of ketones. And Dr. Crawford and Dr. Newman have both written really extensively about this. So if you could, Dr. Crawford, if you wouldn't mind telling us a bit more about now what we know about the non-energy roles of ketones.
Yeah, it's remarkable in its diversity, and it's really amazing because every time we write a review on this, it's by the time it comes to print, it's nearly not quite obsolete, but it's certainly incomplete because the amount of rigorous research that's materializing in this domain is rapidly accumulating. But as we know it now, we can think of ketone bodies as really two partners, two chemical entities that are highly structurally related. One is beta-hydroxybutyrate, and beta-hydroxybutyrate is the one that is most commonly incorporated into exogenous ketone therapies that include ketone esters and other innovative forms of delivery that many on this panel have devised and are experts in. But there's another form of ketone bodies called acetoacetate. So these two molecules that are highly structurally related and actually chemically interconvert with each other in the body in a number of different sites. They each have different ways that they can work so that they can proceed through metabolism and be burned differently, if you will, within mitochondria, the powerhouse of the cell. And they can also signal in distinct ways. And that is to say, they can sort of serve as a beacon, but they can sort of tickle different receptors or serve as keys for different locks, if you will. And that the way in which these different ketone body molecules engage their locks is quite distinct in a variety of cell types. And what we're learning is in many contexts, this seems to be very beneficial for the health of a cell, a tissue, an organ, or even an entire organism like a human. So this is very provocative, as you can imagine, and very exciting. So one of the ways that emerged about 7 years ago or so was to serve as an anti-inflammatory agent. That is to say, to quell or suppress the sort of smoldering fire of inflammation that very often can drive obesity-related cardiometabolic disease, which is so-called sterile inflammation, or can also drive infectious processes as well. So the notion that ketone bodies like beta-hydroxybutyrate may be able to quell or suppress inflammation is a very provocative idea. In addition, it's quite notable that ketone bodies like beta-hydroxybutyrate are also able to help reprogram a cell, if you will. So the sort of the brain of a cell, which is within the nucleus where the DNA is, that sort of guides the architecture and the framework for what that cell will do, can be influenced by beta-hydroxybutyrate. And it seems to do so in a very largely salutary way, a beneficial way. So this is obviously very exciting as well in a variety of contexts. And there are other signaling capacities that beta-hydroxybutyrate has. And in addition, acetoacetate has its own repertoire of activities that are actually quite distinct and remarkably not very overlapping. So this provides an incredible diversity and opportunity for understanding ways in which we can apply ketone bodies to a variety of health-oriented circumstances.
Yeah, so much information in that, and so many places we could go. But I know I want to really focus in on one of the topics which you mentioned a few times, which is exogenous ketone supplements, and that's where a lot of my work is focused. And I really like that you highlighted that different types of ketones that could be formulated into these ketone compounds could have different effects. But I just want to make sure that everyone in the audience who may not have heard of what an exogenous ketone is before gets the masterclass from Dr. Newman. So Dr. Newman, could you explain a bit about, exogenous ketones, why we think they're useful, how they might fit in with people following a ketogenic diet, why they might be similar, why they might be different?
Sure. Thanks, Brianna. I think one of the reasons why ketone science is, kind of captures the popular imagination is because, as Peter was saying, it's such powerful biology that's within each of us. So you can do things like, eating a ketogenic diet, as Jonathan talked about, lowering your carbohydrate intake, or fasting, and your body makes ketone bodies. So ketogenic diet and fasting are ways of making your body do that work for itself, of making ketone bodies. But wouldn't it be nice if there were a way to kind of bypass that and just eat or infuse or administer ketone bodies directly? That's what exogenous ketones are. It's not ketogenic diet in a pill, because a ketogenic diet involves lots of other biology, as Jonathan was talking about. You're eating less carbohydrates, you're lowering insulin, you're changing your glucagon, you're changing your glucose. But for a lot of applications, we think the key thing there is the production of beta-hydroxybutyrate and acetoacetate, the ketone bodies. And through exogenous ketones, you can deliver those directly. It's more complicated than it sounds, and this is where this field has really been the heart of a lot of technological innovation in the last few years, to solving the problem of how to deliver ketone bodies as a food or a supplement, or even as a drug. Because your body runs on them like food. When you're on a ketogenic diet, your liver can make 150 grams of ketone bodies a day. So 150 grams is a pretty big pill. And you can't just, eat spoonfuls of ketone bodies because they're small molecules that are organic acids. So each molecule of beta-hydroxybutyrate is either an acid or has to be associated with a molecule of sodium or some other salt. So you need some really kind of sophisticated and creative tricks to turn these into molecules that you can literally eat a meal of. Ketone esters are one method for doing that, and are probably the cutting edge of exogenous ketones. Ketone esters are molecules with a bunch of building blocks glued together, all of which, once they enter your body, turn into ketone bodies through one mechanism or another. One of the kind of exciting things about ketone esters for applications for aging and treating disease is that they can be customized and optimized in ways that a ketogenic diet or fasting, it's harder to do. So you can make ketone esters that are more about beta-hydroxybutyrate or more about acetoacetate, as Peter was saying. Or as we learn more about the downstream clinical applications of ketone bodies, you could adapt ketone esters to the pharmacokinetics or pharmacodynamics and the target engagement to really get exactly what you want for the biggest impact. The other exciting thing about exogenous ketones and ketone esters is it really broadens the scope of who can benefit from this stuff. Not everyone can do a ketogenic diet, and not everyone could do it for the rest of their life. But ketone esters are more like a food or a supplement or a drug, in that it doesn't matter what else you're eating or what else you're doing. So they can be applicable to a much larger and more diverse population, including older adults, as I'm interested in.
Yeah, excellent. And for me as well, one of the really key bits about exogenous ketones, one of the key attributes is that you can apply them really acutely in certain settings, like in brain injury or maybe acute heart injury, where if you're on the ketogenic diet, it would take hours and hours or maybe even days to really build up that natural ketone production. So that's another big advantage, I think, of these edible exogenous ketones. So that's all really helpful background. Hopefully everyone learned a little bit of something there. But why we have you all here is because we're all really interested to hear about what you're all doing in your labs and researching right now. And you all have very seemingly disparate areas of interest, all the way from metabolic health, heart health, brain health, immune system. And it might seem a little bit incredible to some people that ketone biology could be affecting all of those. But I think as we're starting to hear, there are some common themes coming through. So we are going to start to hearing from Dr. Little. If you could talk a little bit about how you've been utilizing both endogenous and exogenous ketones in your research in metabolic disease, that would be great.
Sure, yeah. So, we know that about 1 in 10 Americans or British or Canadian adults have type 2 diabetes, and probably 1 in 3 has prediabetes. So type 2 diabetes is a big issue, and many people would say it threatens to bankrupt our healthcare system. So we've known for a long time, actually, that a ketogenic diet or fasting is beneficial in diabetes. So 100 years ago, there was physicians at University of Michigan and Harvard who were using low-carb diets and starvation or fasting to treat diabetes. And in those times, we didn't know the difference between type 1 and type 2 diabetes. We just knew that symptoms would get better with these treatments. So certainly it's been around for a while. It's kind of being rediscovered now. And then the role that ketones themselves may play is what we're very interested in. I'll take a quick sidebar that the reason why, there's many reasons maybe why ketogenic diets or fasting ran out of favor in type 2 diabetes treatment in the last 100 years. But one thing that always comes up is this idea of ketoacidosis versus ketosis. And they're very different, but I guess they sound similar. So sometimes people get them mixed up. But ketosis that we're talking about is controlled. It's blood ketones that are between 0.5 and maybe 3 millimoles. And you can't really get much higher than that with a ketogenic diet or exogenous ketones or fasting. Ketoacidosis is uncontrolled. It mostly only happens in type 1 diabetes, people that can't produce any insulin, and the ketone levels skyrocket, and a bunch of other metabolic dysfunction kind of runs out of control. So that's a little sidebar. But our interest in exogenous ketones in type 2 diabetes was kind of by accident. So we knew of this older work on ketogenic diets and fasting, and then we actually saw one of your studies, Brian, I think, in athletes where exogenous ketones lowered glucose. And we were saying, this is kind of interesting. And we dug into it. And around the same time, Dr. Newman, Dr. Crawford were publishing these cool studies showing all these signaling properties of ketones, and they could lower inflammation. So we kind of said, hey, maybe lowering glucose, lowering inflammation, tapping into ketones might be beneficial. So we started a series of studies, starting in young, healthy humans and working our way through individuals with obesity and now in type 2 diabetes to show these glucose lowering effects of ketones. And we've also shown some effects on immune cell function, which are quite interesting and promising. So one area that we don't really understand is actually how ketones or the exogenous ketones are lowering glucose. So we're doing some tracer studies right now to try to figure that out. And if the mechanism is through something that's dysfunctional in type 2 diabetes, this would be really exciting because we now have a natural molecule that can help correct metabolic dysfunction and lower glucose. And one area that that we still need some development on, it's certainly an area of growth, and it's been getting a lot better with the new technologies and scientists and new molecules. But the taste of these supplements, the exogenous ketones, tends to not be great. So it's getting better, but for long-term treatment in metabolic disease, taking it every day is still something we need to overcome.
Yeah, I'm someone who's drunk a lot of ketone esters in my time, and I'm a little bit immune to the taste now, but I can see how to someone who's used to drinking Diet Cola, the exogenous ketone ester would be a little bit to adjust to. But yeah, you hit on so many important things there, and I'm really pleased to hear that you're going to be running tracer studies, because this question of glucose lowering, I mean, it has impact for diabetes, but also metabolic dysfunction is a huge risk factor for heart health, brain health, and many other diseases as we age. So that's kind of a nice segue over to Dr. Crawford, because I know a lot of your work that I've seen recently has been in the heart, but in your introduction, you were talking about a whole ton of other areas that your lab is researching. But if you wouldn't mind, could you talk to me a little bit about ketones and the heart function, and how ketones might be impacting, say, heart failure?
Absolutely, Brianna. So this is an incredibly hot area, the nexus between ketones, ketone body metabolism, and heart failure. And I'll also note, but not focus on, the notion of vascular or blood vessel health as well, which is obviously central to cardiometabolic disease pathogenesis, is also very much on the radar and a potential benefit and target for ketone therapies. But interest in heart failure, and what is heart failure? What that means is when the heart is unable to pump and match the body's demands. And typically what this leads to is fluid backup and accumulation. This is a condition that unfortunately over 6 million Americans suffer from. And this can be associated with a heart being enlarged and weak, and that is to say it doesn't pump blood very well. Or, and that's about half the time, the other half the time, the heart can't relax and open and accept blood very well, even if it squeezes pretty well. And there's great interest in understanding the fuel utilization by the failing heart. One of the hallmarks of the normal heart is it's able to flexibly move among fuels. So carbohydrate, fats, ketones, whatever may be delivered to it, it can move among them very well. The failing heart tends to get locked in and very rigid with the type of fuel. But it's recognized that ketones may provide a window of opportunity that may improve the function of the failing heart. And rationale for this emerged actually decades ago, when it was first realized that the body may already be trying to adapt by elevating its own source of endogenous ketones, that which are produced from the liver, in a way that could protect the heart, could make it work better in the context of failure. But this effort by the body may not be sufficient. So the notion of including exogenous ketones as a mechanism to improve heart muscle function or improve the way the heart performs in the context of heart failure is of great interest right now. So this is of great interest in clinical trials that are ongoing. And this is ongoing in preclinical studies in animal models as well, both large and small. This has not been easy because the figuring out how much ketone the heart may benefit from over what phase of the 24-hour cycle it may benefit the most from it are challenges. But these challenges are not insurmountable. And I think there's a great deal of excitement in this space. And I think there's reason to be optimistic in the context of heart failure and also other drivers of cardiometabolic disease, as I mentioned, including vascular or blood vessel disease as well.
I'm just going to go straight on to Dr. Newman, who works on ketones in the aging brain, and he's also a practicing geriatric physician. So can you talk a little bit about how your clinical experience has actually impacted your research and how you think about ketones as a countermeasure for declining brain health with age?
Yeah, we'll see if I cover your thought, Brianna. So as a geriatrician, I'm really focused on the complex multi-system problems that affect older adults. And these include things that we think of as traditional diseases like heart failure and coronary disease and lung disease. But also the more kind of complicated multi-system, multifactorial geriatric syndromes like dementia and frailty and delirium. Now, I think one of the most exciting advances in medical research in the last 20 years, which is beginning to really come to fruition clinically, is how we've learned that those complex syndromes of aging and many of the diseases of aging are driven by biology, are driven by biological mechanisms of aging that we can understand, we can categorize, and we can intervene upon. And ketone bodies fit into that framework. So one of the common changes that happens in all of our cells as we age, as Peter alluded to, are changes in metabolism, especially changes in glucose metabolism. This is not just about diabetes or metabolic disease, but this actually affects most of our cells in most of our organs, including especially our brains, but also our hearts and our muscles. So the change in the ability of the brain to process glucose, to turn glucose into energy, is thought to be one of the major driving factors underlying dementia, things like Alzheimer's disease and other neurodegenerative conditions. It's also one of the factors that underlies frailty. Frailty is this complex slowness and vulnerability that affects many older adults, makes them less able to do things that they want to do, and also makes them more vulnerable to serious problems. For example, more likely to die of COVID. Frailty is a syndrome that has its roots in basically all of our body, from our brain to our muscles to our hearts and everything. But a common thread, including in our muscles, is again this impairment in generating energy from glucose. So there's been a lot of interest, starting with the brain, I think, and now exploding with the heart, in using ketone bodies to bypass that difficulty in turning glucose into energy, and trying to use that to overcome these changes from aging. What Peter mentioned about our own bodies' attempts to kind of ramp up our own ketone body production as resilience is also really interesting, and might be a factor in why some people age in a more healthy way than others. We're trying to research that in my lab too. But I'm really interested in how how ketone bodies and the ketone system can protect our brains from dementia by supplying that energy, and also doing these other sophisticated biological things like reprogramming gene expression that Peter described a little while ago. I'm not just interested in dementia, though. I'm also, as a geriatrician, interested in what's one of the most important problems that most of you folks have probably never heard of, unless you've been so unfortunate to see it in a loved one when they were in the hospital, which is delirium. Delirium is an acute confusional state that happens to people when they're really sick, especially older adults. It's why someone is, completely themselves, taking care of business, gets sick, goes in the hospital, and then becomes a completely different person. The good news is it's usually reversible. The bad news is it usually also has long-term lingering effects that that increases the risk for dementia dramatically, and increases the risk for other health problems down the line too. Delirium is very similar to dementia, Alzheimer's disease, in its mechanisms, in that one of the features is an acute impairment in glucose metabolism. So that's one of the reasons why I'm so interested in studying ketone bodies, the ketogenic system, and especially exogenous ketones, in trying to better understand complex geriatric problems like delirium and frailty, and trying to learn whether exogenous ketones can become useful therapies by targeting not just the energy metabolism, but these other mechanisms of aging too, like reprogramming gene expression. And I hope this is going to be part of a kind of a new generation of geriatric therapies that lets us, more specifically target and improve, prevent, and treat these, seemingly insurmountably complex geriatric syndromes.
Totally. And I think one thing that strikes me is that ketogenic therapies were used in the 1920s to treat epilepsy, drug-resistant epilepsy, when there were no drugs available. And then, as Dr. Little mentioned early on, we had the ketogenic diet being used to treat diabetics, and it really kind of like fell out of favor for a number of years. And in recent years, we've seen more and more people from a kind of consumer health or like a diet perspective following a ketogenic diet. But I've just got back from a meeting about ketogenic therapies for multiple diseases, and it seems like the interest across so many different therapeutic areas, whether it's the brain, the heart, metabolism, mood disorders. I mean, like the list of areas that people are looking at ketone metabolism for is just exploding. So yeah, in my career, I've seen, even in the last 10 years, these exogenous ketones go from being just a super fuel for athletes and military folks to now being investigated across these multiple disease states. So it's terrifically exciting. But I mean, obviously there's still a lot of questions that we need to answer. Some areas are closer than others, and there are still a number of challenges that need to be addressed. So I'd love to hear from all three of you, specifically where you think exogenous ketones could have the very biggest impact, and what are the key research questions and challenges that need to be addressed to get there. So Dr. Little, if you wouldn't mind leading us off.
Yeah, sure. I think the biggest immediate impact for exogenous ketones is probably the effects on the brain, as Dr. Newman discussed, and as a potential treatment for mild cognitive impairment or dementia. That's probably where we have the biggest, closest impact. But for myself, the effects of ketones on the immune system is most exciting, and where our research is going to go. So clearly our immune system and metabolism are linked. There's a whole new field of research called immunometabolism that studies this. And with the hormone-like and the signaling and the epigenetic, as well as the fuel aspects of ketones, it just is super exciting to see how these molecules might be able to affect our immune system and provide that resilience in metabolic disease, aging, and other conditions. So, and I think in general in ketone research, and especially with exogenous ketones, because they allow us to do this, is more well-conducted randomized control trials and clinical studies in humans. So we can take the biology and the knowledge, and then we can translate it to a potential treatment, get it closer to the clinic, because unlike a ketogenic diet or fasting, the exogenous ketones allow us to dial in and control ketosis for these types of human studies.
Excellent, thank you. What about you, Dr. Crawford?
Yeah, so this is an incredibly exciting time in this field because there's so much opportunity, there's so much to learn. I share the view of the panelists that I think the greatest opportunity for inroads in terms of health amelioration lie in the domains of neurodegenerative disease and cognitive dysfunction, as well as the prospect of heart failure, and then finally regulation and control of inflammation and modulation of immunity in a protective manner. There's, as exciting as this is, and quite an opportune time because of the provocative findings in each of those spaces that are supportive of moving forward boldly and assertively in this domain. There remain many unanswered questions that we are compelled to understand at a mechanistic level so that we can begin to fine-tune our understanding to subpopulations that are going to benefit the most, as well as understanding any possibility for adverse effects that may emerge in a small minority that we can get a handle on prospectively, for example. So, very broadly speaking, we need to understand how ketones are working in a given context. Are they working as fuels that are burned? Are they working as fuel additives, if you will? So you could imagine adding something to your engine and improving the fuel performance or the utilization of the primary gasoline fuel. Do ketones serve in that capacity? And or do ketones serve primarily as a signaling molecule? The good news is we have the tools to dissect these questions, whether they're pharmacological or genetic tools or screening approaches in chemical biology. We can address this, we can do this now, and this is obviously what the folks on this panel are devoted to understanding and working towards in terms of drilling into these mechanisms. So again, really excited about the possibility in the spaces of neurodegenerative disease, cardiometabolic disease, especially heart failure and regulation of inflammation and immunity, but much more to go in terms of understanding mechanisms, because there's such a repertoire of mechanisms through which these can proceed, which is going to have implications again on study populations that are going to benefit the most. And this is going to facilitate our clinical trial design to try to understand where we're going to get the greatest effect size and also mitigate any untoward effects, which we don't really expect much of, but nonetheless, we need to be ready for anything.
Yeah, I think two things that you said there are important to address. Like, firstly, we know that ketones have these multiple mechanisms. So rather than a conventional drug, which may work more in a more targeted way on one pathway, ketones are going to be interacting across multiple pathways that could be of benefit. And then we're going to move on finally to hear from Dr. Newman about where he thinks that ketones could have the biggest impact.
Yeah, thanks, Brianna. Everything that Peter just said, that was a fantastic summary of the state of the field. And like you said earlier, Brianna, this is a field that, much like the longevity science field as a whole, is ready for clinical applications. We've made such advances in the basic biology, in the preclinical science, and have such a great toolkit already emerging, ketone esters and other exogenous ketones and so on, and tools for measurement and biomarkers. This is ready for clinical applications. That's where I think the that's where I think the leading edge is right now in the ketone biology field. And like Peter said, there's a few elements to that. There's still things we need to learn at kind of a basic level about for particular applications, whether that's neurodegeneration or whether it's the heart or other organ systems. How much do you need to give, and in what kind of pattern, and what are the mechanisms that are the downstream mechanisms that are most important, fuel, signaling, other things, because that now we have the tools to take that knowledge and turn it into really precisely designed molecules and therapies. We need to learn more about that for other conditions. So Peter and others, I really admire the work that they've done in making the heart and heart failure really the leading edge, I think, of the clinical application of ketone bodies, and in terms of our mechanistic understanding of what they're doing. And they really plowed the field for understanding that when the body starts making more ketone bodies in heart failure, it's not part of the problem, it's part of the body's attempt to create a solution, to compensate, to become more resilient. And we know that's true for the brain too. What about for other diseases, other organ system problems? There's aging affects every tissue in our body. For most of them, we don't know at that level of detail what ketone bodies are doing as we age. So there's a lot to still learn. I think there's a lot to learn from even epidemiology and human genetic studies about how our ketone body system helps to protect us as we age. And there's a ton to learn from clinical studies. It's been really exciting for me, as it has for you, Brianna, and Peter and Jonathan and others, to see, like you said, this explosion of early stage clinical trials in the last few years, which has been enabled by these tools like ketone esters that have been developed. And we'll be part of that in trying to understand the role of ketone bodies in frailty and in neurodegenerative disease. There'll be much more of that. And that's going to help to further refine what diseases, what applications will benefit the most from ketone biology. And what's really cool to me is are the opportunities for technology development of creating customized molecules, customized therapies that are really targeted precisely to what ketone bodies need to do the most to help the failing heart, to help the failing brain, to help other organ systems. It's a really exciting time to be in this field.
Yeah, no, I couldn't agree more, and I'm sure all of the panelists feel the same. And hopefully, after this webinar, a lot of the audience are going to go away and learn more about all of the different research going on in this field, because it's certainly an exciting area to be following right now. So we are getting towards the end of our time. I want to make sure that we have time for a few audience questions, but before I move to questions, I'd just like to invite all three of the panelists, if there was anything that was said that you want to build on, or any further comments that you want to add that you think we've missed that's important, you have an opportunity to do that now. And if not, we'll go straight to questions.
Let's take some questions.
Okay. So we have one question come in where someone has asked, what are the potential long-term implications of daily elevation of ketone bodies in addition to high glucose and insulin? So I know, at least Dr. Little, that you'll have thought of that because you've studied these compounds in populations where they already have dysregulated metabolism. So maybe you would like to start.
Yeah, so if I understand the question correctly, I would just correct it. I would say if you're taking daily supplementation with ketones, you're probably going to have lower glucose, not high glucose, and the exogenous ketones do induce a small increase in insulin secretion. So you may be in a situation where you have elevated ketones, slightly lower glucose, and a little bump in your insulin. The long-term implications of that is very bluntly, we don't know. We've conducted 14-day studies with 3 times a day ketone supplementation showing lowering glucose. As Dr. Crawford mentioned, we saw this really cool effect of improved endothelial function, blood vessel function, and some effects on immune cells. So we think it's exciting, but it's certainly early days. We've got a 14-day study in patients with type 2 diabetes going on right now, and a 3-month study. But to my knowledge, the longest study published of continuous ketone supplementation multiple times a day is 28 days long, I think, right now. So
28 days in healthy adults with a couple of compounds, but also a recent study from the University of Oxford that did 28 days in type 2 diabetics, I think. So I mean,
yeah. So long term, I don't know if you can call 28 days long term. In this field, it is at this stage, but the effects, I don't think we really know, other than that it does seem to lower glucose and appear to be safe from those studies, I would say.
I don't know, Dr. Crawford, whether you have any thoughts about, on a sort of a mitochondrial or a cellular level, what it might be doing to energetics to have both high levels of ketones, glucose, and insulin all at once, or whether you'd prefer not to comment.
Oh, no, absolutely. I'd love to. So it's really just on Dr. Little's, the heels of Dr. Little's comments, I think we have to think about ketone bodies, their ability to execute functions in a number of ways. And again, remember, one of the original themes that we articulated as a group at the outset, and that is these are normal physiological substances. This is something our body normally makes, and moreover, we've seen this through billions and billions of years of evolution. So that doesn't necessarily mean that everyone needs maximum octane ketones all the time. And in fact, I think one of the key questions is going to be understanding this notion of flexibility. I think, at least in humans, how ketones evolved was to adapt to different circumstances and to actually undergo oscillations and fluctuations. And one of the really interesting questions as we move forward in the design of trials is going to be understanding what kind of frequency and magnitude of effect we're looking for. It may well be that we don't want a sustained ketosis 24/7. We may actually want these oscillations, and that's really going to be where we begin to hit a sweet spot. And coming, to your question, Dr. Stubbs, with regard to mitochondria, that may be, in fact, exactly where we find that sweet spot, because engagement of the powerhouse of the cell, or mitochondria, is going to probably be executed through a function in which the mitochondria are having a chance to sort of rev up and rest, and rev up and rest. And it may be that ketone bodies provide that key to sort of engage them optimally in a way that can help them rev up with the least input energy, so that they can be as efficient as possible, and also recharge as well, and actually kind of get both sides of that spectrum really from one biochemical process that really is quite natural, but leveraging it through a variety of different pharmacological approaches.
Yeah, that's super interesting. And I think it makes total sense that we have macro rhythms to, say, seasonal rhythms in food availability in our evolutionary past. We have circadian rhythms day to day going on as well. And it makes a lot of sense to think that an ideal kind of ketone administration regime could also be somewhat pulsatile. It's just much more difficult to construct a study that gives you all the possible permutations of studying that kind of thing. So what we've seen in the space is that people they pick a relatively arbitrary level of ketones and they try and hit that with their diet or their supplement, and that's kind of considered to be the marker of success. But there's sort of circumstantial evidence from trials of a drug class called SGL2 inhibitors, which suggests that it may be that really even very low levels of ketones could be having an effect. So this is a really central question for the field, like how much and how often do we need to expose the body to ketones to get these therapeutic benefits, and one that I hope that we'll start to see being addressed in the near future. So I'm afraid, everyone, that we are running a little over time, and so I'm not able to take any more questions, but I have been told that we are going to follow up with everyone who asked a question. So please just watch out for that. At this point, I'm going to hand back over to Jim Mellon, the other co-founder of Juvenescence. I may have got his title wrong, but he's an important guy, and you'll want to hear what he has to say to close out the webinar. So thank you very much to all the panelists, and over to you, Jim.
Thanks, Brianna, and thank you so much for the other panelists. It was absolutely fascinating. And some of you may not have seen this, but this is what ketone ester powder looks like. And this is a jar that I've got here in the Isle of Man. It does, as Brianna alluded to, taste not very nice, but it's obviously extremely good for you. Now, the bottom line is that at Juvenescence, which was co-founded by Greg, who you saw earlier on, and Det Dugan, who's probably on the seminar, and by myself, being the co-founders of a number of other companies, one of which, Biohaven, was bought today, just today. We are so excited about the field of the science of longevity, which the Buck Institute, which is our partner in this, is the world leader in. And but we're still at the what you might call the dawn of the internet, the dial-up phase of the internet in the science of longevity. There's a long way to go before we can all take a pill or we can take a therapeutic that will allow us to live healthier for longer. But we do know that some things are beginning to work. And one of them is this ketone powder, followed by a suite of other products that Colin Watts and his team will be releasing onto the American market first, and then to the European market and other markets later on in the course of the next year or so. And the great thing about this is that it's a product that's come to market very quickly because it's made of what's called generally regarded as safe ingredients. So it's been approved by the FDA, but it's very science driven. It's not a supplement that's just sort of plucked out of thin air. This, as you heard earlier on, this ketone ester science is really well developed, and Brianna and her panelists are right at the forefront of this. This is a highly potent supplement that which is basically a nutra-pharmaceutical that we should probably all be taking, and there's going to be a sequence of other ones that come along. Now, the great thing about that is that it leads us into the prescription products that will deal with things, as the doctors on the panel have talked about, such as heart failure, which is one of the biggest killers in the world and for which there is no good treatment. And so in association with the Buck, we are now beginning to develop these what are called RX or prescription products, which are based on the early consumer-driven but science-based products that Juvenescence is bringing to the market. And so for us, it's been a great thrill to have so many people on this, participating in this seminar. And we are going to do, I think, a bunch of other ones over the next few months. So I hope you'll all tune in. And thank you very much, Brianna, for so brilliantly moderating this panel today. Thank you.